Alright, before we start today, I want to point out Morgan Franco's robot that she made. All of my 7th and 8th grade students went ahead and did a coordinate system little project while I was gone, so my sub had them do these. And we had a little competition, so Morgan won overall. I have a bunch more hanging up around my room, but she was the overall winner, so I wanted to point that out before we started today. And it'll be hanging up on my board all week. So let me get this situated here. I know this camera is a little crooked, but it gets the job done. There we go. So we'll jump into the lesson today. And congratulations, Morgan. I really liked how she did that. So today this is lesson 32 for 7th grade, and we're talking metric system today. It's pretty straightforward, pretty basic. Here in the States we use our own units of measure, but we also do use the metric system quite a bit as well. So we use our U.S. customary system, but it's very important we know the metric system as well because the rest of the world uses the metric system. Alright, so the things we want to accomplish today. We want to understand how the metric system works when it comes to measuring length, mass, and capacity. And we want to be able to convert between measurements. So, be able to convert different lengths to other lengths, mass to other mass, and different capacities to other capacities. So, capacities, that would be like our volume, and we'll get into some of these things. So, first we're going to start with length. And these are the conversions between different lengths in the metric system. Their common unit of length, or the unit that they use, or I should say the base unit, I guess, is the meter. So everything's based off of the meter. And the meter, so you've probably seen a meter stick before, but we can say things like 10 millimeters is 1 centimeter, and these are both smaller than a meter, as you can see, because 1,000 millimeters is 1 meter, 100 centimeters is 1 meter. That type of thing. So the nice thing about this chart, and that you'll be able to find out in some of the other things that we look at, is everything seems to go by tens, which I think is a very smart way to set things up. I myself, I like to think of, well, I like to use the metric system for that reason. It's easier to go up by tens and things like that than some of the weird ones that we have. Since I've grown up with those things, it's been easier. But I like having this. It's a little more structured, easier to deal with, and less memorizing for me. And our last one here, 1,000 meters is 1 kilometer. And me being a runner, most of the races that I run, or at least I used to, were in Ks. 5 kilometers would be a 5K. Sometimes they call it the 5,000 meter run. They've got 10Ks, things like that. Although a lot of my races also are told what they are in miles as well. So miles would be a common one, especially here in the U.S. Alright, so our prefixes here, we've got kilo, hecto, deca. This is our standard unit, meter. Desa, centi, and milli. So they use the units of length here, and they've got all their abbreviations here as well. But you can see that it goes up by tens or down by tens based off of the meter. So 1 meter, a decameter would be 10 meters, hectometer would be 100 meters, kilometer would be 1,000 meters. And if we go down, we're going down by tens. This would be 1/10 of a meter, a decimeter. Centimeter would be 1/100th of a meter, and a millimeter would be 1/1000th of a millimeter. So this is a nice chart to use, and it helps us convert. So I'll show us how we can do that. It says 5 kilometers is how many meters? Well, let's find kilometers here. And we're saying we've got 5 kilometers. And they want to know how many meters that is. Well, let's look at kilo and figure out how many spots we need to move to get to meters. So we're going from kilo meters, 2 meters. We're going to go down 1, 2, 3. So we went down 3 spots, that means 3 zeros. So this would be 5,000 meters. That's how we can use the chart to do this. It makes things a lot easier that way. You also could have just looked at this chart and said, okay, I know that 1,000 meters is equal to 1 kilometer. So 5 times 1,000 gets us to 5,000. That's the other way we can do it. Alright, let's see here. 300 centimeters is how many meters? Okay, this one I'm going to use the more mathematical way. So 300 centimeters is how many meters? Well, 1 centimeter, or let's see, yeah, 1 centimeter would be 1/100th of a meter. So 300 centimeters should be 3 meters. That would be 300 times 0.01. So we should get 3 meters. Let's see if that makes sense here. So 300 centimeters, we'll start here, and they want to know how many meters that is. So we're going to go 1, 2 to get to meters. That means we're going to move our decimal spot, which is right here, but we're going to go to the left this time. 1, 2. So we still get 3 meters. 3.00 meters. So we still get 3 meters either way you do it. So yeah, when we go from the bottom up, we're going to move our decimal to the left that many spaces. If we go from the top down, we're going to move our decimal to the right that many spaces. Otherwise, you can just do it the mathematical way, where we actually do some multiplying in order to figure that out, which is fine. I like that way too. Alright, the only unit of capacity they have here is that 1,000 milliliters is equal to 1 liter. But all of these prefixes still apply, so we could have had liters here instead of meters. So it could have been we could have kiloliters, we could have hectoliters, decaliters, liter, deciliter, centiliter, milliliter. Those are all fair game. And same goes for our units of mass or weight. They just give us a couple. 1,000 grams is 1 kilogram. 1,000 milligrams is 1 gram. Alright. So if we look at this here, and just point out these could also go on the chart too. You could have a decagram, a decigram, a hectogram, that type of thing. Just matters on what you're talking about, length, capacity, or weight or mass. Alright. So if we look at this one here, a 2-liter bottle can hold how many milliliters of beverage? Well, 2 liters, let's figure out what 1 liter is first. It says 1 liter is equal to 1,000 milliliters. And here we have 2 liters. And that equals how many milliliters? Well, it looks like from 1 liter to 2 liters we're doubling, so we're just going to double this. So this should be 2,000 milliliters. I want to make sure we can see that. So lots of different ways to do these conversions. That way was kind of like setting up a ratio. Alright, let's take a look at this one quick. How many 250 milligram tablets of vitamin C equal 1 gram of vitamin C? So milligrams to grams, we want to figure out how many of these, so 250 milligrams, will get us up to 1 gram. So let's see, we know that 1,000 milligrams is 1 gram. So we want to see how many of these go in there. So we would do 250 and see how many times it goes into 1,000. Or, cross one of these out, that's 25, goes into 100, and we know that 4 of those go in there. So, it would take 4 250 milligram tablets to equal 1 gram of vitamin C. So those are some things we could do there with our conversions. Alright, I believe this is our last one. And we're doing okay on time. So we also have a temperature scale for the metric system. And we also can see that on our side here, in Fahrenheit, this is what we use. But, you know, we use both of them as well. So, their Celsius temperature scale, we use Fahrenheit. Celsius, this is when water boils for them at 100 degrees Celsius. Normal body temperature would be 37 degrees Celsius. Room temperature is 20 degrees Celsius. Water freezes at 0 degrees Celsius. So, once again, you can see they set their temperatures so that water will freeze at 0 and boil at 100. So, and there is a way to convert between the two. We're not going to get to that quite yet, but we will soon. And they will use that in science quite a bit. Alright, hopefully you can see this one. I think you can. Want to check? Yep, looks good. It says a temperature increase of 100 degrees on the Celsius scale is an increase of how many degrees on the Fahrenheit scale? Okay. Well, 100 degree increase would be from 0 to 100. So we're looking at this right here. That's a 100 degree increase. Okay, so what increases that on the Fahrenheit scale? Well, looks like it's from here, from where water freezes to where water boils. So we're looking at from here to here. That's 212 degrees and 32 degrees. So we'll subtract those. So 180 degrees Fahrenheit difference. Okay? So an increase of 100 degrees here on the Celsius scale is an increase of 180 degrees on the Fahrenheit scale. So that's a brief intro to our metric system. We'll get into that more so next week with some examples and in-class work. And we'll be seeing this in math as well as science for quite a long time.